Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 9.1.4, which is Transformations of Functions. And after today's lesson, you should be able to make generalizations about how to transform functions, both horizontally, vertically, and stretchy and compressy. And so we're going to start with this basic function right here, this y equals x squared. And if you want to, take a second and just figure out what the numbers are. If you want to pause the video, and then you can catch up in a little bit. But we should hopefully know these by now, that the parabola is going to grow symmetrically, and that if we square all the terms, we'll get those values. So if I put this into the graph, then I'll get 0, 0, 1, 1, 1, negative 1, all this stuff here, 2, 4, negative 2, 4, 3, 9. And the parabola should grow like a parabola, because that's exactly what it is. And so we've got that. We've got this function right here. Okay. And so notice how nothing's really happening to it, right? It's centered at the origin, so the center is 0, 0. And with nothing else happening on the inside or the outside of this function, this graph right here in its current form is generally known as a parent function. Now, all types of functions have parent functions, and a parent function basically is the function in its original form, meaning no changes like vertical or horizontal shifting or stretching. Now, within my definition, unfortunately, I had to use some words that you probably weren't familiar with. I said, notice how there are no changes happening. There's no plus or minus anything. There's no shifting. And so I will show you what that looks like right now. When I talk about a change in the function, I'm going to give you guys an example that looks like this. If I say to you now, instead of y equals x squared, I'm going to call this guy on the left side, I'm going to call him y equals x plus 1 squared. Notice how he's different. There's a plus 1 on the inside. When I talk about the function itself, I'm hoping that you guys will see that the function itself is the x squared. And the way things are going to get plugged into this particular function here is I'm going to plug in for x, I'm going to add 1, and then ultimately the function will happen to it. It will be squared. And so let's go ahead and take a look at what that does. I'm going to use the exact same numbers that I did last time, and we'll see how the plus 1 on the inside affects the graph. So negative 3 plus 1 is negative 2, squared is 4, negative 2 plus 1, that's going to get me 1, negative 1 plus 1 is going to get me 0, so 0 squared is 0, 0 plus 1 is 1, and then 1 plus 1 is 2, squared is 4, 2 plus 1 squared is 3 plus 3 squared is 9, and then 3 plus 1 is 4, squared is 16. So I apologize, I moved through that a little bit fast, but hopefully you were able to kind of keep up with the computations right there. But let's see how this affects this graph right here. So I'm going to go and do this graph here in purple. And so from here, let's go and plot the points. So let's start with 0, 1. So 0, 1, it doesn't really matter where you start. 1, 4, so 1, 4, 2, 9, and 3, 16 is off the graph, but we don't really need to worry about him. We'll know how he goes. Negative 1, 0, 2, 1, negative 2, 1, sorry, and then negative 3, 4. So from here, when I go to graph this thing, I want you to start noticing the differences and the similarities between the graph that we have over there in red and the graph that we have here in purple. How are they different? How are they the same? Well, they're the same in the sense that the shape is, generally speaking, the same, right? It's a parabola. It grows in a U shape. The center of this particular parabola is negative 1, 0. So in some ways, we could see this parabola as maybe shifted to the left by how many spaces? By 1 space. Now, I'm assuming and I'm hoping that you'll know what caused that shift to the left by 1. It is not a coincidence that we are adding a plus 1 on the inside of this parabola, and suddenly this thing moves to the left by 1. So with that in mind, let's go and move over to the right side, and we'll do another version. And I have to, hang on, pause, and I'm going to expand the screen a little bit so I can fit all three on one page. Give me a second. And we are back with some more space here, so sorry about that. I had to expand, and I actually wrote down the next problem here. It's y equals x minus 1 quantity squared. And so again, I'm going to do exactly what I did last time. I'm going to go and compare this to the parent function, and then I'm going to see how the minus 1 affects the graph. Now, bear in mind, remember, when we did a plus 1, on the inside, it moved the graph to the left by 1. Knowing that, I think you might be able to do this without a table, but it's okay if you can't. It's not a big deal. We can do this with a table. I'm going to plug in a 0. I like to start at 0. It's easier for me. Plug in a 0, so 0 minus 1 is negative 1. Squared is going to get me positive 1. And then if I plug in a 1 into here, 1 minus 1 is 0. 0 squared is 0. I'll plug in a 2. 2 minus 1 is 1. 1 squared is 1. Plugging in a 3. 3 minus 1 is 2. Squared is 4. Negative 1 minus 1 is negative 2. Squared is 4. Negative 2 minus 1 is negative 3. Squared is 9. Negative 3 minus 1 is negative 4. Squared is 16. And again, like all parabolas, notice the symmetry here. Notice the symmetry where we should have expected that to happen. In other words, that indicates this thing is the center. This thing is the vertex. So I'll go ahead and do that here. I'll go ahead and draw it in dark green. So 1 comma 0 is my center. 2 comma 1, 3 comma 4, 0, 1, 1, negative 1 comma 4, negative 2 comma 9. And again, we'll be a little bit off grid here, but I feel like we can kind of make this thing work. So here we go, right here. Now again, I want you to notice what do they have in common? What do the graphs have in common? What do they have that's different? The shape generally is the same, just like our parent function, the red function. But the center is, as you guys I'm sure have predicted by now, is at 1 comma 0, indicating a shift to the right by 1. And again, I don't think it's a coincidence that we just so happen to throw down a minus 1 on the inside of this parabola. So let me see if I can generalize our horizontal shifts for us. When nothing is happening on the inside of the function, in other words, nothing is happening before the squared, we're centered at 0. We throw down a plus number, in this case 1, on the inside of the function, in other words, before the squared. I throw down a plus 1. That creates a horizontal shift to the left by the number in question. In this case, a plus 1 indicates a shift to the left by 1. If I throw down a minus 1 on the inside of the function, in other words, I throw down a minus 1 before the function happens to it, then what I get is a shift to the right by 1. So let's see if we can come up with a generalization for our horizontal shifting. So when it comes to horizontal shifting, a plus or minus on the inside of the function before the function. And I also want to throw down one more thing. Notice how it's attached to the x term. Okay? That results in a horizontal shift of the function. And let's go ahead and make it very, very specific. Addition on the inside creates a shift to the left. Subtraction on the inside creates a shift to the right. So the way I've always seen it is it's always opposite your intuition. Whenever you have a plus or minus on the inside of the function, it creates an opposite of your intuition effect. So there is your first transformation right there. I'm going to clean up the board real quick and we'll be back for the second round. And we are back with the next round of transformation. So again, I kept the parent function up here just so we could make comparisons to how transformations affect the parent function. But if we look at this one here, this x squared plus 1, one of the first things to note is that unlike the last set, this transformation, this +1 is happening, I call, on the outside of the function. So the squared will happen first, and then we will add 1 based on our order of operations. So from here, 0 gets me 1, 1 plugged in gets me 2, and then 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10, and it's going to keep on going the way we symmetrically do it. So from here, I'll go and draw this one in black here. So 0, 1 is my center. 1, 2, negative 1, 2, 2, 5, negative 2, 5, 3, 10, and then negative 3, 10. So I think by now the transformations in this vein should be relatively obvious. Notice how the center here, the center is 0, 1, and the transformation was happening on the outside. So notice how it compares to the original parent function. We are now shifted up by 1. And so on the other version, I'll go and put it up here real quick. We've got y equals x squared minus 1. And actually, I'm pretty confident at this point, you may not even need a table to do this. And if you don't, it's okay. You can fast forward through and go and let me know what you think it's going to be. But if a +1 on the outside of the function resulted in a vertical shift of up by 1, let's see if we can reasonably predict what's going to happen here. So this is going to be negative 1, this is going to be 0, 2 squared is 4, so minus 1 is 3, 8, so that's going to be 0, 3, 8 here. And you guessed it right on the money here, that a -1 on the outside would result in a downward shift by 1. Downward shift by 1. And so there you have it. There are your rigid transformations of these parabolas. And so so from here, actually, I'll go and label the center also. The center is 0, negative 1. Let's go and make a generalization out of this as well, like we did for the horizontal. And we can basically say that addition or subtraction, oops, I gotta watch my typing there, addition or subtraction on the outside of the function, in other words, after the function happens, results in a vertical shift of the function. Addition shifts the function upward. Subtraction shifts the function downward. So, with these rules in mind, how does this help us? Well, it helps us graph these things rather quickly. And on top of that, this idea of the function transformation applies to all functions. So if I give to you something, and we saw this in vertex form, if I give you x minus 3 squared plus 1, if I'm being asked to describe the transformations, well, I can say, well, it looks like there's a minus 3 happening before the function, right? It's happening on the inside. So I know that it's being shifted right by 3. And then this +1 tells me that we're being shifted up by 1. And incidentally, as we saw in the last video, our vertex is at 3, 1. It's at 3, 1 based on our vertex form. And it's an upward facing parabola because we haven't done any kind of non-rigid transformations yet. And I know that it's not going to be super accurate, but as long as I have a good idea of what this graph is going to look like, then I'm going to be solid snake on this one. So that is the advantage of knowing these transformations. Let me go ahead and do another example here. If I say, okay, instead, if I say y equals x plus 4 squared plus 2, then I can make my transformation generalization. I know that it's shifted right, not right, but left by 4, and it's up by 2. So from here, I can go left 4, up 2, throw down my vertex, and I know that it's going to be upward facing, and if I just have to sketch it, then I'm just going to go ahead and sketch it like this. Again, another example here. I can go and throw down another one. I can say y equals like x plus 7 squared minus 4. Well, what does that tell me? There's a plus 7 before the function happens. It's to the left by 7. There's a minus 4 on the outside after the function happens. It's going to be down by 4. And I can go ahead and draw that in. So left 7, down by 4. Right here. And it's going to grow up like this. And just because I feel like it, I'll go and throw one in the 4th quadrant here. If I wanted to do that, I'd create one that was shifted to the right by, I don't know, 5, and maybe down by 7. So again, that's right 5, down 7. Hopefully you can see that blue there. To the right by 5, down by 7. And it's going to grow up like that. I hope this makes sense to you. If not, please leave comments or questions in the comments area, and I will see you in the next episode.